Hi there! Today I'm playing with literal junk again. I have a USB charger, and the USB charger itself isn't very exciting, but interesting is there was a recall. The company Digitec, one of the largest online distributors for electronics and other stuff, sent us an email and telling us this charger here is unsafe. We should discard it, throw it away, and we will get our money back. And well, so far everything is okay. But besides of this email here, there is no information on the website of the distributor. There is nothing to find on Google or anywhere about recalls in general from this company or also other companies. It seems that recalls aren't really popular, of course. And yeah, it's a little bit a mystery. Interestingly, if you search for recall on the website of this distributor, you find mostly meat grinders. So there are no recalls listed on their own website. Now what they say is there is an insulation problem here, and that maybe under some circumstances some metal parts may conduct some voltage that could probably shock you. That's more or less how they wrote it here in the mail. So what I want to do today is to find out, can we see a problem when we open that? What's up with this power supply? Let's have a look inside. And well, let's see how easy it is to take apart. Maybe I try this side first. No, I think there is a little bit the gap. Okay. Yeah, I need better tools. Okay, that was relatively easy. Okay, interesting. No soldering, just plug and play somehow. Yeah, that's pretty simple. Okay, how does that work? Yeah, that goes in here. Yeah, so that's how they assemble this. They just put that part in and then glue or weld the cover with the contacts. Okay, so what do we have here? So at the first glance I don't see any problem here. It's surprisingly well built. It has a real fuse here. You can see that connector here goes to the fuse. Then we have a
full bridge rectifier.
Then we have the switching transistor IC here. That turns the transformer here on and off. Primary capacitor. Then the secondary from that transformer is on this extended leg here, which reaches far into this isolated zone here, and also the isolation here is very wide here. It's almost, how much is that? That's 5, 6, 7 millimeters. That's certainly enough for around 300 volt maximum. In fact, that's probably okay for 7000 volts. Also, the optocoupler here is a very long device that is made for high voltages. There is an interesting chip on the secondary side, which is basically, or which has basically the function of a diode. So that's, you can imagine that's just a diode, but it's an active rectifier. It's a synchronous rectifier, as they call it. It basically checks for the zero crossing of the signal and then turns a MOSFET on or off. And that has, of course, a better efficiency than just a plain old diode, but the function at the end is the same. And then we have this little daughter board here with the USB-C connector, and on the back side, of course, the chip that is used for the negotiation of the output voltage and output power. Let me see. The output voltage is 5 volts, 15 watt, or 9 volt, 20 watts, or 12 volt. Yeah, so 5, 9, or 12 volt. And yeah, that's what this little chip here does, together with the chip on the other side of the device you want to charge. Okay, so far that everything here looks fine. Insulation is fine. There are at the end two possibilities that could be a problem. It's this capacitor here, because that goes from the primary side to the secondary side, and if that capacitor shorts out, we will get probably mains voltage on the ground here, because that connects, yeah, that's most likely the ground rail here to, well, that side. That's for RFI noise reduction, stuff like that. The other problem could be the transformer itself. If the primary and the secondary side is not insulated well, so that could be a problem. Otherwise, I don't see any problem. I mean, the PCB itself is almost impossible to fail. Yeah, so let's check the capacitor. The capacitor doesn't look suspicious. It has all the safety markings. It is rated X and Y for 400 and 440 volt AC. It's also rated 250 volts AC, so I don't see a problem here. I mean, you never know if these markings are all genuine, but at least it looks okay. Well then, let's see what the transformer does. I noticed some ferrite core fragments all over the transformer. Could this be a safety problem? I don't know. So let's take the transformer apart, and you will notice there is a tiny little wire going from one of the primary pins to this core or shield or whatever. Let's see how this is made. And I would say there is something wrong with that, because normally there is a a copper band going around the core, and the wire here is connected to that. But here there is no copper band, there is nothing, just insulation tape and the ferrite core. And the ferrite core itself is a very bad electrically conductor. It's a good magnetic conductor, but electrically it doesn't do much if there is a wire or not. So I think they forgot the shielding, or they left it away on purpose, I don't know. And here we can see one of the first primary windings. This transformer has more than one primary winding. I think it's a primary winding and a feedback winding. Maybe that's the feedback here, because it's only a few turns and it's a relatively thick wire. After that there is another layer of insulation tape. It's a pretty good wrapping. It's 4 or 5 times around the core. So I think that's not a big deal here. That's a very well insulated layer. It's probably the same winding, so they insulated the individual layers of the same winding. It's also a primary winding. Then there is another layer of insulation tape, and underneath that is the secondary winding. You can see these thick wires, and they also added some additional insulation tubing for the exposed part of the coil. So there is another layer of insulation tape. So actually, I don't see a problem here in this transformer. It looks pretty well made, and a lot of insulation between the individual layers and also the individual coils, primary, secondary. So this one is probably the main primary coil. Eventually, at least it goes to the primary pins there. And here's yet another winding. I don't know, maybe that's the feedback winding, because it goes to these 2 extra pins there, which are also on the primary side, but probably have a different function. And there is one pin that is not connected to the PCB, so it only serves as a connection point for 2 or more wires. That was the last winding. As you can see, nothing special, nothing bad. Everything looks pretty well.